PyRun.
Hello? Okay, first the official part. My name is Marc-Andre Lemburg. The title of my presentation is Shipping the Python 3.7 runtime in just 4.8 megabytes, PyRun. My presentation will be in English. I consent to being recorded during my presentation. I consent to having my pictures taken during my presentation. I will comply with the PyConGP Code of Conduct. That was the official part. And now let's move on to the fun part. Right, I'm going to give a talk about a project that I've been working on for quite a while. It's called PyRun. First, a short speaker introduction. I'm Marc-Andre Lemburg. I have been doing Python for many, many years, since 1994. I'm one of the Python core developers. I am a founding member of the PSF. I'm the EuroPython Society Chair, lots of other things. In this talk, the most important part is that I'm a core developer. A bit of history. So going back to 1997. In those days, it was not usual that you could, at your web hoster, get Python support. They had Perl support typically, so you could upload CGI scripts in Perl and then run them. Some even had Bash support, so you can run Bash as a CGI script. But it wasn't possible to run Python. And of course, at that time, I wanted to run Python for my web apps as CGI script. And I thought, well, how can I get Python installed on the server without actually having to ask the web hoster to do this? And I tried around a bit. Of course, being a CGI bin directory, things that you put in there were executable. So I thought, well, if I put an executable up there using FTP, then I can sneak in Python and then run Python that way. So what I thought is, in order to make this happen, I couldn't upload too many files, so I wanted to have an easy way to deploy Python to the FTP server. And the way that I wanted to do this is to have more or less just a single file to upload. And then I also uploaded a Bash script, which then turned that uploaded file into an executable, and then I could run that executable as a Python interpreter. So I worked with a tool that I'm going to show in the next slide to make this happen, or one of the next slides. To make this happen, I initially supported Python 1. I think it was 1.2 or 1.4, one of those two. And I made this project open source. It attracted a lot of attention at those times because many other people had similar projects, similar problems and wanted to do a similar thing. And because I made it open source, people then downloaded the code for this, ran the code, and created these single file binaries for lots and lots of different Unix systems. So like Solaris, HPUX, all kinds of other systems that you probably nowadays don't hear anything about anymore. That was very successful. Of course, at some point, the hosters realized that Python support is something that's nice to have, and so they added that. And the reason for the project became, well, it wasn't that useful anymore for this purpose. And then the project slowed down. In 2003, I essentially stopped working on it. But then, fast forward to 2009, I was working on a product which I wanted to ship to clients. And I had a problem because I have a small company and we cannot support lots of different platforms. So supporting a product on many different Linux distributions was nearly impossible. So I remembered that I had this project, the MXCGI Python, a while back, and I decided to then revive this and make it work again. Didn't take too long to make it work with the then current Python versions, so that was a good solution for us. And then for Windows, we used Py2Xe, which does a similar thing. So we had a solution. So what were the business requirements that I had? I wanted to have a way to ship a single executable with the complete, or more or less complete, Python runtime, everything that you need to run an application, including the complete standard library, And I wanted to be able to put that file on a Unix system and then have the application run. I wanted to support several different platforms: Linux, FreeBSD, Mac OS X, or Mac OS. Nowadays, most other Linux distributions should work as well. It doesn't support Windows. Could be made to work on Windows, but for Windows we don't really have a need, so we're not putting any time into that. So let's go to that tool that I just mentioned. How many of you know the freeze tool in Python? Just very few. So freeze has been around for ages. It was written by Guido himself. It was written in the very early days. He wanted a tool to turn Python bytecode, or let's say Python modules, into C extensions that could be loaded into Python. And the way that the tool works is it takes the bytecode, it puts the bytecode into C static arrays, and then has special support code within Python to be able to import modules that way. What you then do is you link that, you compile the C file that's generated, you link that statically into your interpreter, and then you can run things. Freeze has been, well, wasn't used for a very long time until a few years ago when the import lib was written. The import lib had as you probably know, the import lib is written in Python. So you have a bootstrap problem. How do you import the import lib if you need the import lib to do the import, right? So in order to solve that bootstrap problem, what was done is the freeze tool was used to then compile a subset of the basic tools that you need for the import lib into the interpreter, so that you don't need an import mechanism to actually load things. You can just directly run the import statement and everything will work. So nowadays freeze is being used again. When I started to use freeze, it wasn't supported, so I had to make a few tweaks to freeze to make it work. And so with the Python 3 versions that we have now, we can now rely on that freeze tool again, and everything works nicely. So what's the secret sauce behind this? How do you get things into a single file? First of all, what you have to do is you have to see that all the standard lib modules that you want in this one single executable file, you have to compile all of those into these, using the freeze tool, into these the extensions that then get linked into the main binary. Then you have to see that you have to look at all the C extensions that Python uses in the standard library, and you have to make sure that the ones that you want to have in your executable are statically bound, not compiled as a shared extension as they normally are. So you have to make that work as well. The way that you do this is you go to the module setup file that you see when you download a source package of Python. How many of you know this file? Even less? 2 people? Not really much, or maybe 3. So the way this file works is it's very much like a make file. You can configure in that file which modules to link into the interpreter. You can configure which files to compile in a shared way. And of course, by editing that file and then saying, okay, I want these extensions to be statically linked into my binary, you can then make sure that the C extensions get linked into your executable. Plus, you can make sure that using the freeze tool, by adding to this file as well, you can make sure that those extensions also get loaded into the interpreter. So this is basically the mystery behind how this whole, the original MX CGI Python and now the PyRun tool works. You can, of course, also add your own extensions to this. So if you have Python modules that you want to have in that application, you can just add them to the file, and then Freeze will then pick those up. You can also add the C extensions to the file, and Freeze will then also pick those up, and during the compile process, everything will get built into a single executable. Right, so the original intent was to just run a single Python script from that executable. But I thought, well, it would be nice to have a command line interface as well. It would be nice to be able to interact with that Python version, to have the REPL. And so I decided to basically emulate the Python command line on the command line tool in the package. Unfortunately, because the way that the command line is being parsed in Python, this is being done in C. And the way that PyRun works, I have to do this in Python. So I had to rewrite large parts of the command line parsing in Python and then compile everything into PyRun. And I had to do this in order to make some tools that and many of you probably also use, pip and setup tools, and also wanted to make it possible to have the PyRun itself be able to compile C extensions. So essentially what I wanted to get at is a replacement for the standard Python command line tool. That I achieved. I implemented everything that I needed. I don't have everything implemented from the command line. It's sometimes a bit tedious to do that because some of the features are not documented. Some tools use features from the command line which they should not. And I had to make everything work, so I had to work around a couple of things. But over the years, I managed, and everything is working nicely now. I even added interactive use, so you can have a REPL. You can go into basically the interactive command line as you can with a normal interpreter. Plus, I added an extra feature where you can add a zip file to the executable at the end, so you can concatenate the executable with a zip file, and then PyRun would automatically run the code that's in that zip file. So it's extremely easy to build applications with just a single file without having to compile anything. Right, everything is open source, so you can download it from the website. It currently works with Python 2.7, 3.6, and 3.7. Porting to new versions is also very easy. And I have achieved to make it work on Linux, FreeBSD, Mac OS. It's not working on Windows, as I had mentioned. If you need earlier versions than 2.7, which I hope by now no one needs, then you can download previous versions of PyRun. The executable size that comes out of the tool is when you compress it using UPX. UPX is a compression tool for executables. You can get it down to 3.7 megabytes to 4.8. 3.7 is for 2.7, Python 2.7, and 4.8 is Python 3.7. So that is quite amazing. If you look at the code sizes here, you can see that the 14 megabyte file up there, that's uncompressed. And then if you run the UPX tool on this, you get down to 4.78 megabytes. And you have a standard REPL. You can run any application using this. And I'm using this tool a lot to, for example, replace virtual envs. So I don't create virtual envs anymore. I just copy this file around, and then the binary has a logic to find anything that you want to add to that binary. Like, for example, if you want to pip install anything, then you can have a directory set up. If you put the binary into a bin directory, and then you have a lib directory associated with that, and the pip will then automatically put everything in there. So what can you use this for? Obviously, like I mentioned, you can ship packages, you can ship products with this tool. Because of its size, it's extremely easy to install. It's extremely easy to download from somewhere, so it's ideal for Docker containers. If you do a Docker image, for example, you're usually, after having the image be very, very small, because you want to be when you deploy things, you want to have everything run very fast and set up very fast. This is possible using PyRun. It's much, much smaller than a regular Python installation. So that's one use case. It's probably also interesting to use for mobile app applications if you run them in Python. I don't know how well this would work, but since Android is Linux-based as well, I suppose that it would run there as well, using some tweaks, of course. And of course, it's a great tool to just, let's say you have a colleague, the colleague doesn't have Python installed, then you can just ship that binary, and the colleague can just put the binary somewhere, run the script without having to install anything, and everything just works nicely. There are probably many other use cases for this as well. But those are the most obvious ones that I came up with. So let's have a look at how you can build a single file Python application using the tool. It's literally just concatenating the tool with your zipped application. And then what Python will do is it will look in that zip file for a dunder main.py module. How many of you know that one? Yeah, also a few, not too many. I think the feature is not well publicized enough because it's actually very useful to have this. What Python will do, it will run this main file. The main file will work just like what you typically have in a Python script, where you then do the if name equals main, except that in this case you don't have to use this. You can just directly put your code there. Python will run this and then execute the application and then provide the interface that you have to find in there to the outside world. So all you have to do is you concatenate and you make it executable and then you're done. You don't need to compile anything. You have a single file, that's your application, you can send it around. You can have many packages, many modules in that zip file, basically your whole application. So how can you customize PyRun? So how can you make it do things that I did not put into this per default? So like I mentioned, you can, if you know how the freeze tool works, you can add extra C extensions, you can add extra Python code to the executable. You can have everything nicely built directly into the binary. So this is different than using the zip file approach. In the zip file approach, you still have the zip file that needs to be unzipped. By using freeze, you have the bytecode directly in C. And of course, because it's directly in C and it's directly loaded with the process, it's in process memory. So loading happens much, much faster than having to load something from the zip file. You also have to edit the module setup a bit if you want to make changes. If you want to have, for example, extra extensions that come with the standard lib enabled, then you have to edit that file. If you want to have C extensions that are not part of the standard library, you want to add those to the binary as well. For example, when I'm using a stream example, maybe NumPy, you want NumPy in there, then you can make that work as well. It just requires editing this module's setup file. Let me just maybe show you how this works. Just a second. There you go. So this is how the directory works. If you go in here, can you read that down there? Yeah. Oops, that's a zip file. So there's a dunder main in there. And then if you look at that dunder main, that just says hello world. What else would you expect? And then you have two versions here. One is hello PyRun. This uses the uncompressed version, so you can just show that one. Well, it gives you hello world, and this is the compressed one. Works as well. And if you run PyRun, let's say the compressed version, then you get your standard REPL here, and you can do standard stuff. And as you can see in this directory, I also installed pip in here, so you can pip install things. The pip that's in here automatically uses the PyRun. Right, so I obviously ran a few tests. So one of the tests is to import and run Django, run the tests in Django. Also some couple of other things. Python, for example, is included as well for testing. Now what I wanted to show is something else. So this is the standard setup. And this is where you get to the details. So let me just show you the module setup file. it's called setup, sorry. Setup PyRun 3.7. There you go. That's how the setup file looks. Like I said, it's very much like structured like a make file. It's a very long file. It's well documented. This has been around for ages, so 1997. In 1997, this was the way to write C extensions, so you actually had to write these files, and then there was no pip, there was no setup tools at those times. You actually had to write a make file and then run it to make it work. These are the standard ones, the standard modules that get compiled in statically. And then at some point in this file, there's a statement saying shared. There you go. This line normally is uncommented. And then everything that comes below it is compiled as a shared library. So what I did here is I basically commented out that line, and then everything else that you have under here gets compiled in statically. And of course, you can add stuff down here at the very end. It's fairly easy. You put your C file somewhere, you put the name of the module there, and then everything works. Right. So that's the module setup file. This is a short example of what it takes to port PyRun to a new Python version. So I did the port to 3.6, and then this is the port from 3.6 to 3.7. So it's actually fairly easy to do. It's not a lot of work. You have to, of course, check whether new modules got added. You have to check whether the patches still work. Sometimes the import logic changes, sometimes some of the lookup logic changes, then you have to go into the patch and fix a few things. Oh, sorry. There are usually new modules that you have to add. So it's fairly easy to do. Every now and then the environment variables used for compiling Python change, so you have to make that change as well. I'm shipping a version of Freeze with the tool that I maintain myself, so it's not the standard one that you have that comes with Python. The reason is that I need to make this work with multiple Python versions. And so this one was very easy. The one before the port to 3.6 took a bit longer because Victor Stinner had changed quite a lot in the mechanism to run Python, and so that took longer. Right, so this is it. You can download the latest binaries and also the older source version from PyRun.org. That version does not support Python 3.7 yet. I haven't gotten around to actually uploading the source files to GitHub yet. I want to do that after the conference, and then you can find everything down here at the company's GitHub account. I will also put up links on PyRun.org to download things. Thank you very much.
Thank you very much, Marc-Andre. We have about 5 minutes for questions, if anybody has a question. Okay.
Hi. You showed pip freeze output, and that included a certify module. And I was wondering whether PyRun is able to roll in the certificate authority root certificates within the executable, or whether root certificates are still an external file.
So this is a good question, because there are indeed a couple of things that you have to tweak in order to make things work. Because Python itself, when it compiles, for example, it uses the grammar, which it reads from a file somewhere. Normally, and the grammar is being copied into the installation. Now, of course, with Python it doesn't work, because the file itself would then be in the executable and you cannot point it there. So you have to write extra code to emulate this. Now, if you can do the same with certify, then of course this would be possible as well. I'm not sure whether compiling in certificates into a binary is such a good idea, though. So, of course, if you can point certify at a file that actually exists in the file system, then you can make that work. Or if you're willing to, rebuild your binary every time the certificates change, that will also work. So the general problem is with an approach like this is that some packages rely on extra files they're put into the package directories, which don't have anything to do with Python, like text files or, I don't know, some lookup files. Those files are, of course, when you compile everything into PyRun, are not accessible anymore. So you have to find some way to emulate what Python then does or what the package does in order to make those files accessible. And the way that usually works is that you build a Python file out of the text file or whatever that package uses, and then you put that Python file that you have generated into PyRun. Does that answer your question?
Sure.
Yeah. Anyone else?
Is the source also distributed with PyRun in the sense of like,
Yes.
if there's a traceback, you'll see Python code?
Good question. Yes, I had to work around that a bit because normally what Python does, it tries to go to the source file, and then of course it doesn't have the source file because it's just bytecode. So the way that works is you get an entry. I don't know if I can show this. Let me see. Okay, let's go here first, and then here. My typing is not the best today. So let's see what this gives. Okay, that's not a good example. Let's write a test. Also not a good example. Anyone know a standard library that produces errors?
Mm-hmm.
Let's see.
Can you trigger a file does not exist error or something with open?
Well, the point is that it has to reside in some kind of module, right? So that you can see the traceback. Sorry?
Using
JSON, okay. Okay, that is not JSON. That looks good already. So that's... I don't have... let me... So you see the file and then the angular brackets there, PyRun. This is what PyRun does in order to signal that this file is coming from inside the executable. Right. So yes, of course, if you have the source code available, it would show the complete traceback with source code as well.
Okay, sadly we're out of time, so that's all the questions for now. Thank you again very much, Marc-Andre.
Thank you.
For your presentation.
Thank you. I'm going to be downstairs. I have a poster as well, so if you want to ask any questions, you can just come to the poster. Thank you.
Yes, and also right now is going to be the snack time, afternoon tea break. So I'm sure that if you had more questions, you can ask them.